Good evening, and welcome to the Science Frontier Network, where we explore discoveries that change our understanding of Earth's past and our future. Today, we are investigating a groundbreaking study that reveals the Sahara-Arabian Desert, now one of the driest regions on the planet, was once an oasis of rivers, lakes, and thriving wildlife. And the proof? It's been hiding for 8 million years in Saudi Arabia's caves. To break down the complex science behind this discovery, I'm joined by a climate specialist and historical analyst. Let's start with the team behind this research.
Of course, this research was done by an international team led by the Max Planck Institute for Chemistry in Mainz, who worked with the Saudi Heritage Commission and the Saudi Ministry of Culture. Their focus was on a cluster of 7 cave systems located in the Duhul al-Saman region, northeast of Riyadh. And inside of the caves, they found speleotherms, cave minerals like staglamites and stachylites. Now, here's what's so exciting. Speleotherms only form when water is dripping into a cave over long periods of time. So if you find them in the middle of the driest area in the world, you can bet your money that this wasn't dry some time ago.
So even just the appearance of these formations already tells us that the climate must have been radically different?
Exactly. When the team had found them, and they found a lot of them, it meant that the region had experienced continuous rainfall, not just once, but repeatedly over millions of years. But to accurately figure out when these wet periods had happened, the researchers used radiometric dating, analyzing each uranium isotope inside the speleotherms. This allowed them to map out 3 major phases full of rain, which includes the late Miocene, around 8 million years ago, the early Pliocene, around 5 million years ago, and middle Pleistocene, between 700,000 to 300,000 years ago.
That is absolutely incredible. So the caves tell us that the climate was completely different, but climate alone doesn't paint the full picture. So what does the team find within the fossil records that reveals the potential world that existed out there?
The team found fossils of crocodiles, hippopotamus, and elephants, animals that all depend on a constant supply of water. So when the team put all this evidence together, it became clear that it wasn't just a slightly wetter desert, but instead a thriving habitat, a place with wetlands, grasslands, and enough water to support entire ecosystems. But the team's findings go even further. These wet periods created what researchers call green corridors, which are long stretches of vegetation and water that connected Africa to Eurasia. And during these humid windows, early humans and animals could travel across them. Without these pathways created by a certain climate, human migration might have never happened, or it might have happened in a completely different way. So these wet periods didn't just reshape the landscape, but it reshaped our species' entire path to modernization.
That's amazing. It's crazy to imagine that a place we now know as dry and unforgiving was once a highway for wildlife and the migration path of early humans. But of course, this green world didn't last forever. What caused this transformation back into the desert we see today?
Alright, this is where the story shifts dramatically. Around 700,000 years ago, Earth entered what scientists call the mid-Pliocene transition. Temperatures in the northern hemisphere begin to cool, and that cooling period pushed the monsoon systems farther south. When the monsoons moved, the rainfall that once fed the Sahara-Arabian landscape of rivers and lakes began to fade. But here's the important part. Understanding why this happened helps scientists predict how modern climate change might shift rainfall patterns today. By studying these historic climate cycles, researchers can better anticipate which deserts might become green again, which fertile landscapes might dry out, and how ecosystems will change as the global temperatures rise. It's like reading Earth's climate history, written in minerals, fossils, and stone.
A desert with a rainy past, and a future still unfolding day by day. What may look barren today has shaped the journey of our species and may continue to do so as the Earth's climate evolves. Thank you for joining us on the Science Frontier Network. We'll see you next time.